My name is Varun. I will be one of the presenters today. I'm from Google Cloud. I'm the product manager for Google Compute Engine VMs, specifically based on Google Axion, which is our custom ARM server CPU. Uh, we'll be having Timur and Sean join us today, and together we'll be talking about how GCP platform and ClickHouse our customers can see a much better performance and at optimized cost. So that's the presentation today. So let's get started. So I bet everybody in this room can talk for hours on how AI is changing reshaping our industry, changing our day-to-day workflows. And at Google, we are constantly innovating and thinking about our infrastructure, ensuring that we are building out a fungible infrastructure which is optimized for cost, optimized for performance and scale. We are also ensuring that we are able to tackle the trends such as the AI ecosystem evolution that we are seeing recently, while making sure that we are constantly reducing the toil for the customers' engineering teams, um, especially around the automation as well as the orchestration. We are also providing a variety of consumption models to ensure that you have the right choice when you are running on GCP platforms. The infrastructure that we are building, we are ensuring that it is ready for the next generation of the AI evolution, while also making sure that the cloud first workloads, which are the essential building blocks to deliver the AI experience, is well supported, well optimized, while also ensuring that the enterprise first workloads, which are the key cornerstone and the bedrock of running the day-to-day business is well supported, especially the reliability and some of the other key tenets that is required for the enterprise workload. So all of this is supported on the GCP infrastructure. Now, at the heart of our strategy is building out a modern Google Compute platform. So here, the Google Compute platform we are targeting is always ensuring that it is workload optimized, it is TCO efficient, and enterprise ready. The key technology that is enabling our GCP compute platform is Titanium. So Titanium is a technology that is used by Google for a long time to deliver planet scale services such as Gmail, YouTube, search, and much more. Enabling Titanium in GCP infrastructure enables all our GCP customers to run like Google. Now, what is Titanium? Titanium is a system of offloads that removes some of the common bottlenecks of compute, networking, and storage. The benefits you see in your end application will be how the application is running at a good performance, ensuring good storage throughput as well as good network throughput. Now, in our modern platform, we have GCE, which is our Google Compute Engine virtual machines. Here, we offer a variety of very flexible general purpose offering as well as very optimized specialized VM offerings. On top of it, we have the GKE, which is a Google Kubernetes engine that enables you to orchestrate, as well as it has the option called the custom compute engine that lets you select the right compute and the right consumption model. And layered on top of it is the hyperdisk offering, which is our latest generation of block storage that lets you provision the IOPS and the throughput as per your workload needs. So together, this modern platform is very fungible, and it enables our customers to run all the new workloads along with the cloud first workloads as well as the enterprise workloads. Now, zooming in into our Google Computer Engine portfolio, on the left, here we have the general purpose portfolio, and the right we have the specialized compute portfolio. Now, talking about the general purpose portfolio, we have the C series VMs, which is the compute workhorse that delivers the absolute raw performance for our customers. And we have the N series here, which enables and delivers a balance of performance and the TCO. Now, if customers are looking for specialized workloads such as HPC, we have the compute optimized. Now, if your workload requires much higher storage or the local SSD ratio per vCPU, we have the storage optimized. If your workload is in-memory databases and requires much higher RAM ratio per vCPU, we have the memory optimized VMs. We recently launched at Google Next the network and the block storage VMs that delivers much higher networking bandwidth throughput per vCPU. And lastly, on the right, we have the GPU as well as the TPU VMs that is used for inferencing and training. So this is what we have been working for a decade, almost the last decade, and we are very proud to offer the workload optimized compute today. Now we are seeing most of this consumption of the customers in this highlighted bucket, which is the general purpose VMs. So Google, with its Google Axion, decided to focus and deliver its first VM to solve the needs of our customers in this. So Google is not new to developing silicons. For decades, we have been designing custom silicon for our services. And also, you might have heard about, most of the people would have heard about TPUs. We are in our 8th generation TPU, and it is used for serving the serving and training the Gemini models. Now, for expanding that and having the end-to-end very optimized system, we invested into building our own custom silicon based on ARM, Google Axion. We launched this at Google Next in 2024, and the C4A VMs was launched in 2024 October. Now, let's deep dive a little bit about into Google Axion. So, first of all, it delivers up to 10% better price performance than the other leading ARM offering from other CSPs. Versus our current generation x86, it offers up to 65% better price performance, and we are able to do all of this at a 60% better energy efficiency. Now, in today's world where the AI use cases are surging, power is a very precious commodity, and this is definitely helping solve some of those problems. One key thing I want to highlight is this is based on standards, which is a standard core from ARM. So the broad ecosystem support we have for ARM is readily available on Axion, and for a lot of customers who is running on ARM, it's a lift and shift. Now let's look at some of the performance numbers. So the numbers speak for itself here. For Java and MySQL, our customers are seeing around 30% better price performance versus the current generation x86. And from the specs perspective, today we have up to 72 vCPU supported on C4A. We have 576 gig of RAM that lets our customers have up to 8 gig of RAM per vCPU. It comes with a titanium local SSD, which gives you much better throughput and storage performance. And we have 6 terabyte of this on a full VM shape. It comes with 100 gig of tier 1 networking, and standard is at 50 gig. We support all the flavors of hyperdisk, which is the extreme throughput and balanced. And most importantly, it is based on the latest titanium offload. Now, C4A has been in the market for almost 17 months. We have seen our customers run variety of applications on Google Axion, especially web applications, backend databases, data analytics, games, media, and much more. And we have gotten a superb response uh, from our customers, proving the price performance value proposition. Customers have constantly given us feedback that it is very flexible, it is much lower cost, and it goes without saying that Axion is also able to help cater to the next wave of the AI use cases, such as agentic sandboxes, the small model inferencing, the AI pipeline data processing, vector search, and agentic data retrieval. So we're very proud of this product. And if you look now, we are expanding the general purpose bucket, and now we have uh, two more new offerings from Google Axion family. The first is the N4A on the left. So that is based on our latest generation of Axion CPU, and it provides you a very good cost effectiveness and flexibility, which is the balance of TCO and performance. And it comes up to 64 vCPU shape and 50 gig of networking. Now again, it doesn't come with the local SSD, but it does support the hyperdisk. And on the right, we are bringing the C4A metal, which is our bare metal offering, which is in public preview, and you have direct access to the hardware. With this, I want to pause here and see if anybody has any questions. Yes.
So I do understand that you come for years, but today. One second. So let's do a comparison between the Axion CPU versus the current offering from Amazon, Graphicon 5. They do have a much wider DRAM buses than the Axion bus today. And also that one of the challenging that I'm facing with right now is when custom port Kubernetes, the overhead I have to pay for it on the GPC side, and typically it's about 30%. So we have the solution to optimize for me to have to pay the overhead of the Kubernetes on GCP ARM.
Sorry, I couldn't hear, but the question.
If you do custom Kubernetes port in GCP, I had to pay for the overhead of Kubernetes, which is about not small 40%.
Okay.
If I go Amazon, one thing direct to bare metal, I don't deal with the cost of the Kubernetes
it.
overhead, and they offer much wider memory bus.
Okay.
So the execution is substantially faster.
Okay.
For same dollar figures, I have to go to GCP. Is Google have any solution down the road for me to direct access to the core without the overhead of Google Kubernetes?
Absolutely. No, that's a great question. So, what are different ways we can access the hardware? And we are seeing our customers access the hardware two ways. One is the GKE, if you want the orchestration layer and flexibility. And there are a lot of customers who directly use GCE VMs directly. So there is no overhead of the GKE as you are mentioning. So that's another way. And now if you don't want the hypervisor and if you want to bring your own hypervisor, you can definitely go the metal route, the bare metal route that basically gives you direct access to the hardware without any overhead of anything. And of course, we have GKE also supported on it if you want, but otherwise you can basically run bare metal. And especially on the metal side, a lot of the Android and the car companies, which is basically building a digital twin, is using bare metal directly because of the lack of the nested virtualization. So this helps them get to the solution there. I hope that answers your question. Thank you. So with that, I wanted to introduce Timur. Timur.
Hi, everyone. Thank you for joining this session. My name is Timur Solodovnikov. I manage Compute and Networking Group in Data Plane Organization. Today, I will explain and go through our journey of migrating to Axion platform on Google on ClickHouse Cloud on GCP. First of all, I will explain how we run our applications. We'll talk about what's important for our apps, why Axion is a perfect solution for us, and we'll talk about migration and show some results. Okay, let's start with some high-level architecture. So in ClickHouse Cloud, we run multiple GKE clusters, but today I will focus only on one cluster. We call it Data Plane. We run their applications customer-facing application, mainly ClickHouse Server and ClickHouse Keeper. Our requirement is 3 availability zones. Also, we have separated node pools for ClickHouse Server and ClickHouse Keeper workloads. And potentially, well, not potentially, most likely, at even given time, we have multiple node pools for Keeper and Server workloads. There are a few reasons why. One of the reasons is migrating from one Kubernetes version to another. How we do it, we duplicate our node pools and slowly migrate applications from old version to new one. Or another reason is we support different virtual machine shapes. For example, we can run ClickHouse Server on memory-optimized instances or CPU-optimized instances. But majority of our fleet running on standard, where per one CPU, ClickHouse gets 4 gigabytes of memory. Okay, zooming in, let's see how it looks like on a service level. So same Kubernetes cluster. So 3 availability zone. We have, when you create service in ClickHouse Cloud via console, our API server configures infrastructure. For example, we create a Google Cloud Storage bucket. We configure Google service accounts, attach them to Kubernetes workloads. And our API creates manifests of server and keeper workloads in dedicated namespaces on Kubernetes. So that's our way how we isolate workloads. We apply special network policies to make sure that service from namespace 1 cannot talk to service in namespace 2. And as I mentioned before, one of the requirements is 3 availability zones. One of the reasons is we spread our workloads across 3 AZ, and we want to make sure that we can tolerate outage on cloud service provider, and we will be able to serve traffic if at least 2 availability zones are alive. Potentially, services from different namespaces can share node pools or even compute resources. So we are multi-tenant system. We try to utilize our compute resources as much as possible, so to make sure we do not waste any resources. Okay, so that's a high-level design how we run applications. Let's talk about what is important for ClickHouse workloads. In ClickHouse Cloud, we decoupled compute and storage, and we store all data in ClickHouse Cloud on S3 compatible storage. In case of GCP, it's Google Cloud Storage. And it's really important that we have we don't have problems on I/O level because any read, any write, it goes through the network path. Also, we want to make sure that we don't have a bottleneck on CPU level. And at this point of time, we use local SSDs. We cache data from Google Cloud Storage locally. It has a few benefits. First of all, if data is stored on local SSD, ClickHouse will not go through the network path, and it impacts query latency. For the record, our core team is working on a feature called distributed cache. So this feature will eliminate dependency to local SSD on ClickHouse server, not pools. But for now, we still have dependency. Okay, so why Axion is a perfect solution for us? So first of all, let's talk about CPU. On older generation VMs, actually not correct. On x86 architectures, usually most of the servers every CPU is mapped to logical one CPU on operating system level presented as logical CPU. So which means that on VMs with sustained load, hyperthreading may underperform because processes scheduled on different sibling threads can compete for shared resources such as CPU cache. And Axion platform, they do not have multi-threaded, hyper-threading, and every core is actually mapped to one physical core. So it directly impacts query latency. Another thing Varun talked about is titanium chips. So on older generation VMs on GCP, CPU was involved into I/O operations, and with titanium, all I/O operations are offloaded to special hardware. And it means for us that ClickHouse, we have more cycles of CPU for ClickHouse. So, and it's a really big deal. Next slide. So let's talk about migration. In general, if you are familiar with Kubernetes, you just need to deploy additional node pool and update node selector. But in ClickHouse Cloud, it's a bit more complicated. So step number one, we do need to prepare node pools. On C4A VMs, we use C4A standard. Majority of our fleet uses C4A standard shape. And in order to perform rollout and rollback, we control node selectors by feature flag. We have a special process in place. And in order to, for example, if we need to migrate one service to Axion, we enable this feature flag, and our controller will migrate workloads to C4A node pools. This is just a process in general. But we have a lot of services deployed on GCP. We cannot run it manually. We cannot run this process manually. We created automation that picked up services every day and performed migration by running some pre-checks, migrating our workloads, make sure that we don't have any problems after migration. And every day we increased batch size, and that's how we migrate services. It is true for most of our changes that we roll out. It's not just about C4A migration. Okay, so let's talk about some constraints. So as of today, the biggest CPU, the biggest VM that we can use for standard shape is C4A standard 72, which provides 72 CPUs and 288 gigabytes of memory. In reality, we actually have even less memory because some of the memory is reserved by Linux, and also we reserve some memory for internal daemon cells. And in order to, but in ClickHouse Cloud, services may require more memory or CPU, and we need to make sure that we support seamless failover to other VMs. For example, by default, we want to make sure that all services land on C4A VMs, but if pod is bigger than 72 CPUs, we need to automatically fall back to x86 architecture. And with that, we found the cool feature that GKE supports. It's called compute classes. We use it for fallback from Axion to other VMs. Let me explain what is compute class. Basically, it is abstraction. It's Kubernetes object, and it's abstraction that you can map compute class to multiple node pools. So this is example taken from the documents from GCP website. So from the left, you can see definition of compute class, which will use N4 family by default. And if for some reason pod cannot fit on N4, or there is capacity problem or something else, it will fall back to N2. And from the right, you can see how you can actually map your workload to compute class. It's really simple. You need to update node selector and use special format. Google.com, compute class, and name of the compute class. That's it. So it's really useful feature. I highly recommend to try. And it can simplify a lot of things, especially, but we don't use it, but it can even create node pools automatically for you if needed. Okay, so how it works for us. We created a compute class we call it server ARM. We have list of priorities. By default, we use C4A standard 72 VMs, and we fall back to other VM types. So it's simplified pod scheduling process for us, and kudos to GCP team. Thank you. In March this year, we created blog post about migration and posted some test results. According to ClickBench is an open source tool for testing databases. You can download it and run your test to reproduce it. You can reproduce the tests. So according to ClickBench, we are up to 55% faster on C4A. ClickBench runs, if I remember correctly, 46 queries. Take a look, open the blog post, you will find the result for each query, but it's you may think that, okay, this is just test data set and it may not actually align with real workloads, but actually our customers, I want to show you some results of migration of one real customer. In ClickHouse Cloud, you can see we have two metrics here. So let's talk about the metric in the middle. It's average query latency time. So you can see that before, during the day, average query latency was 130 milliseconds on average. After migration, it dropped to 70 milliseconds. So it aligns with ClickBench results. Along with that, we actually use less CPU time. So on the top, you can see that after migration, those workloads started using like 15 CPU cores for around 15, 20 in peak. So we can do more work with less CPU, and as a result, customers will pay less money. So and we have really happy customers with that. That's it for me. Do you have any questions?
If, say, there is a situation when in ClickHouse cluster, one node created on like desired processor and one on fallback, is there any concerns when they will be working on different platforms essentially?
Well, theoretically, there will be unbalanced load. Yeah, that's thank you for the question. That's a great question. We are trying to, we are running ClickHouse in a best effort approach. So we try to move to run all our workloads on C4A. Only if C4A is not available, we fail over to other VM types. But this is, it shouldn't happen in general. Yes.
What does the general capacity for C4 machines look like, especially kind of at the top end, across different regions?
So we don't really have visibility in capacity. Yeah, this is a question for GCP team, I guess. But yeah, unfortunately, I don't have numbers how many cores we use, but yeah, we migrated around 86% of our GCP fleet to C4A architecture. So
across the four public regions?
Yes, across all regions, yes.
Awesome.
So in general, we are in the fleet build mode, and the overall what we are seeing. So we are roughly 5 to 6 quarter in GA, after GA, and we are in the fleet build mode. Since this is a first generation product, the anticipated demand versus the actual demand is like day and light, right? So it's basically crossing every expectations we had. So we are building it out as soon as we can, and that's what I will say is ClickHouse is very important, and we continue to support as best and as fast as we can.
It's a great problem to have.
Yeah, great problem to have. Yeah.
If you're thinking about global expansion, do you think the demand
Varun.
when you're thinking about scaling and global expansion, is the capacity more constrained in the US versus the outside? If you were to give guidance on how do you creatively, deploy where you get the optimal performance?
You absolutely alluded to the right thing. So we are in 34 regions today, and we continue to expand. We have a strong roadmap coming in. You'll see outside some of the big regions where we have lots and lots of customer going in. Outside that, it's relatively better. But of course, with the surging AI use cases, things are in demand globally. But absolutely, outside US, things should be a little better.
Any other questions? No? Okay. Thank you. We can, yeah, we have another one.
Hey guys, my name's Sean. Thanks for coming in today. I'm one of these happy customers running on ClickHouse GCP. Unfortunately, I don't have those beautiful number go down charts, but what I can share is an anecdote. When we went live in February, we did our capacity estimates, and then we went live and we were severely over-provisioned. Double checking my math to make sure I didn't make any mistakes. It was really just the case that all of a sudden we got rugged and the machines were substantially better. So I'm an engineer at Aptos Labs. We are a L1 high-performance blockchain. Yes, we're still around. You didn't get rid of us yet. And the thesis behind our product here is our flagship product, Decibel. It's a fully on-chain perpetuals, futures perpetuals, decentralized exchange. It's a mouthful, but basically think Robinhood, but on-chain. And the conclusion we arrived at last year was that a lot of money and the markets are moving on-chain. Our biggest competitor, Hyperliquid, they have absolutely crushed in the last 12 to 18 months. They have over $3 trillion, or now over $3 trillion of US dollars traded on-chain since their inception. And we're seeing very interesting use cases. For example, with the Iran war, we're seeing a lot of oil futures being traded outside of traditional CME market hours. We're seeing OpenAI, SpaceX, et cetera, all these guys trading pre-IPO. These are futures, no underlying, so we're able to do things like that. Hopefully ClickHouse soon. And we're seeing 70% of derivatives reaching 6% of SEX volume. SEX, like centralized exchanges, are things like Binance or Robinhood, et cetera, Coinbase as well. Great. So we started to build our own decentralized exchange, and here are some stats since our launch earlier in February. $2.5 billion in trading volume since we launched, and we're doing about $1 billion monthly US dollar volume. And we have 45 million dollars that our customers trust us with that trade on our platform. So why do we select ClickHouse? It was a real nice, perfect fit because we rely on blockchain data as source of truth and for current state. And ClickHouse really comes in and fills in all the other gaps. We use it primarily for event sourcing, as well as literally every other use case, BI, production APIs, materialized views to also access state off-chain, as well as obviously utilizing the columnar scans at our massive scale here. Here is a high-level overview of our architecture. We have, of course, our globally distributed chain. You can think about this like a write-optimized database. We have our live event stream into our high-performance Rust indexing layer that writes straight into ClickHouse Cloud in the Tokyo region. This kind of powers everything, as I was mentioning earlier. Our trading APIs for market makers and users to access their trades and orders, etc. Meta-based dashboards for analytics, fee reports, risk analytics, risk alerts, Grafana alerting for on-call, for monitoring the system health, financial health, and infra health, for debugging with our SQL console, and huge fans of the ClickHouse MCP. This entire slide deck was pulled from the ClickHouse MCP. I just asked Claude to write this for me, and this is the second time looking at the slides. Sorry, Alex. So this is a screenshot of our write path over the last week. We have around 150 million rows written. Here's just an idea of the different data that we're interested in: prices, account value, snapshots, acknowledgement events for order acknowledgements, orders, bulk orders, more prices. These are relatively simple ClickHouse design. We have materialized views on every insert to capture latest state, so those are easily queryable without full table scans. We're consistently getting a 220p50 insert latency, which is very nice at the bulk insert scale we're doing. This is a really read-heavy system with over 3,000 times rows read versus rows written. You can get an idea of the gist here: 40 terabytes scanned per week, 8 mils on some lower latency paths, and tail latency of 5 seconds. We also run larger SQL, more like BigQuery-esque workloads on ClickHouse. Here's a glimpse into one of the table architectures that we use. Recall that a trading candlestick is really the perfect feature for something like a columnar store, where you have open, high, close, low for a particular time interval, and we're able to use an aggregating merge tree to capture this very efficiently. So why is Axion very good for our use case? One of the anecdotes I like to share with this particular use case is we shipped very quickly, not 77 days, in a few months, in half a year, and we're able to ship sub-optimized endpoints, and we're just able to rely on the brute force nature of Axion on ClickHouse to make sure that we still meet production ready SLAs. We're really utilizing the memory bandwidth for our column scans. When we initially shipped, we were doing full table scans, and we were still able to get our sub 200 mils SLA. Parallelism is the name of the game. This worked very nicely, and of course the MV refreshes on every batch insert also was able to leverage this hardware very nicely. That's all for me. Here are some key takeaways that we have. ClickHouse runs everything. We're able to use Axion very effectively. You can ship sub-optimized code when you're really rushing, especially in the age of AI, and still really brute force everything you need to. And merge tree family tables plus materialized views was the last step that was able to get us to perform very well. Yeah. Great. Thank you very much.
Any questions?
Hi, thank you.
Is there local flash storage on the platform?
I beg your pardon?
Is the instant running in a local flash storage platform?
For our ClickHouse platform?
Is the flash memory on the platform?
They're running on cloud, ClickHouse Cloud. Is the flash memory tied to the CPU?
Local SSD is attached to the CPU. Yeah, so it's a local SSD, so it's in the same machine, yeah, which is why you will get lower latency.
Yeah, thank you so much, Sean, for sharing your story. When he did the dry run, one of the anecdotes that he shared was they didn't realize that we were doing behind the scenes. So suddenly it went from however long it took to run a query to half the second, and they were like, is this working right? So it was a pleasant surprise. So at ClickHouse, that's what we take pride in, just surprising our users with better and improved performance on a day-to-day basis. Yeah.
Thank you.
All right, that's it. Thank you, everyone.